Today we're going to do number 206, reverse linked list. So we're given the head of a singly linked list, reverse the list, and return the reversed list. So as you can see here, the linked list is 1, 2, 3, 4, 5, and then its reversed is 5, 4, 3, 2, 1. So there's a couple of ways we can do this, and then the first way is using recursion. So the base case would be when node is null or node.next is null. When we're at the last node, we want to return that node. So we're going to recursively call this until we get to the last one. And then as you unwind, that's when you flip. So returns. Here's where we do the reverse. We want to make each node it's a little confusing. We want to make each node's next point back to it, creating a cycle. So we go up to here 5, and now we get return 5. So when we do 4, 5, we want to do 4 to 5 to 4, back to 4, 4 to 5 to 4, and then you cut off the 4 being null. So 4 goes to null, so we just have 5 going to 4. And then break original link. And here we just return the new head. So the time complexity of this is going to be O of 1, not O of n, where n is the length of head as we're iterating through it. And then the space complexity is going to be O of n, because we're creating a call stack with a recursive call as we iterate through this. So how else can we do this? Usually, if there's a recursive way, there's an iterative way. And with that, we can solve it that way. So we want to have 2 pointers. Previous for the reversed part and current for the remaining list. And then we do a loop through code, and within it we want to save the next node because we're going to lose it, and then point it back to the previous. And we want to advance cur and previous. So here's what I mean. We're going to have a previous of null, that's to the outside, and then the current is here. And as we loop through this, we need a placeholder for 2, 3, 4, 5, what's left over. So we create that in a temp variable. You point 1 to next to previous. And this previous used to be at null. It needs to iterate up to 1. And then the current becomes all of this that we had previously, that we stored in a temp variable. And we keep doing that until we get to the end of the list. So the time and complexity, this is going to be O of n, since we're iterating through the list. And then the space complexity is going to be O of 1, since we're just using constant variables. in it. So since this has a constant space, we should go with the iterative solution, but I will show you both. So first, for the iterative solution, we create the variables that previous equals to null, and this is what we're going to return at the end. And then we're going to have a current pointer for this, and it starts off with the head. So while current has a value, this is where we do this replacement, and we need to create a temp variable to hold what's next. So const temp equals cur dot next. And while we do this replacement, I like to, once we assign something as a variable, I like to substitute it next. So here, current dot next. So here dot next, we're going to set it to previously. So previous is going to be null to 1. And now we want to move, since we already assigned this, we want to move up to where it is now. So it should be current. So I'll go to the 1. And now current is what we're going to update now. And we set it equal to temp. Great. So now let's do it the recursive way, and let me just do it here. So we have to have our base case. If head doesn't exist or head dot next doesn't exist, we return that head. So we keep doing this. So we have to call this to get the new head. So const new. And as we do this, this is where we do the flipping. So we create the cycle first. So head dot next dot next. So when we go back, we get this 5, and then we go back to the call stack for dot next 5. Dot next would be null, but we're going to set it back to 4. And since it's back to 4, now we cut the ties with the 4 be going to null. And we can just return the new head. Great. So there's 2 ways we can solve this. The first way is to use recursion. And the base case is that we want to go all the way down to where we get the 5. And then when we go back up, we want to create a loop of the previous self and then cut the tie. So it creates the new, it reverses each one until you're all the way back up to the top. Or you can use 2 pointers where you iterate through it. So we have a pointer at the current to start off, and then we want to create a new variable previous for the reverse part that starts off with null, and we're going to iterate through current and flip it as we loop through. That's all. Thank you.